Hey students, in this video I'm going to go over areas of regular polygons. It is a second part to what we did in class on the previous notes of 10.4, so please watch this video. It does require you to do some extra math. For example, we have special right triangles coming back. The application of the relationship of the sides of x squared of 2 for 45, 45, 90, and then x squared of 3 for 36, 90. Also, SOHCAHTOA comes back just because if you don't have these special right triangles, you're going to have to use the relationship that SOHCAHTOA creates with those angles and sides. So I'll give you some examples here. The first one is asking you to find the area of a triangle. And if we approach it with this formula applies to all regular polygons. But I just want to show you that if we approach it with that formula, it will look something like this, where you would have to find the angle of the inside part here, then identify what type of triangles you have, and if it's a special right triangle or a SOHCAHTOA scenario, and then that only gives you your apothem, but then you still need to do perimeter and that formula. So to save you time, there are other formulas we could use here. For example, the triangle formula, which is 1/2 base times height. And in this case, we need a base, which we're given, but we also need a height. And we're talking about the height of the whole triangle. So we are looking at a right triangle that's created by half of the 14. So only this part, so that's 7. And we don't know how long this height is, so we put question mark. And we do know what this side is because it's a regular polygon, which means that all the sides are equal. So this is a 14 right there, which means we now have a scenario of Pythagorean theorem needed to be finding that missing side. So a squared plus b squared equals c squared. C is our 14 because that's the hypotenuse. Let's just say this is a, and then b is 7. So then if we're solving for a, we're going to end up subtracting 7 squared from 14 squared. And then whatever that is, we're going to have to do the square root of that to cancel that squaring. So in reality, to find a, we need to do the square root of 14 squared minus 7 squared, which is, in other words, hypotenuse minus leg squared. And then just type it all in one step. So square root of 14 squared minus 7 squared. And the answer is 12.12. So a equals 12.12. So that part, all that work was just to find this height for this middle part of the triangle. So this is the height. And now that we have the height, we substitute it here. And then the base we said was 14. So 1/2 times 14 times 12.12. So all of that combined should give you the answer. Times 14 times 12.12. So 84.8 meters squared is the area for this triangle. And I'm just going to compare this to what I showed you earlier. This is using the special right triangle route, and we didn't get the exact answer, but we got similar. So that just proves to you that there's other methods to getting the area. Okay, so the next one is a pentagon. And this one, it's only giving you the side. You need to calculate what that apothem part is in here. So this is the part where you have to get creative and visualize that this pentagon can be split into triangles. So you can either see it as there's 5 triangles in here, and you find the area of one triangle and then multiply it times 5. Or you could follow the formula that's right here. 1/2 times the apothem times the perimeter. So we're going to try that. So to find the apothem, we need to first understand that everything around in here is 360. So 360 divided by 5 will give you what one piece of a triangle is. So 360 divided by 5 gives you 72. So that means that one of these triangles has a 72 degree right there. We're looking for the apothem. So if this triangle has 72 degrees right there, we only need half of it. So we could find the apothem right there. So this part, so 72 needs to be split into 2. 72 divided by 2, that's 36. So this angle right there on the top for this part is 36 degrees. But then we know this is 90, because that's 90, so this is 90. But we need to find out what this angle is now. These are all isosceles triangles. So if this is 72, these two have to be equal. So inside we have 180, 180 minus 72 will give you the inside angles, which is 108. So these two together is 108. So we're going to divide 108 by 2. And we get 54. So each one of those is 54. And again, we're only focusing on one part of this because that's the one that will tell us the apothem. So this is 54. Okay, so sideways, we know that this holding is 10. So if this holding is 10, half of that will have to be 5. The apothem is what we don't know, so we can just put it as an X. Now this one, this is not a 30, 60, 90 or a 45, 45, 90 like the special triangles right here. So we're going to have to do SOHCAHTOA. We're going to apply that relationship. So we are going to pick an angle to work with. Let's say we do 36. We need to identify how that 5 is related to the 36, so it's opposite. And then this X is related to that 36 by being adjacent. Remember, the hypotenuse is always across the 90 degrees. So we only are using adjacent and opposite here, which if we recall from SOHCAHTOA, that will be this one, tangent. So we're going to write tangent of angle 36 equals opposite over adjacent. So opposite is 5, adjacent is X. And then this takes us back to previous units where we solved for X using this. So we're going to multiply times X on both sides. That cancels the division. And then this X times tangent of 36 equals 5 now needs to be isolated for X. So we need to divide both sides by tangent of 36. So that means this is now gone. And in our calculator, we're going to type 5 divided by the tangent of 36, and that should give us what our X value is. So 5 divided by the tangent of 36, and it's 6.88. So all this work was just to find the apothem. So we can label this as being the apothem. All right, so now that we have that, we go back to the formula, and the formula is just asking us to do 1/2 times the apothem times the perimeter. So 1/2 times 6.88 times the perimeter. The perimeter of this pentagon is 10, 10, 10, 10, and 10, so that's 50. And then we just type that in the calculator. So we have 1/2 times 6.88 times 50. So 172 is the area for this pentagon. Okay. All right. On the next one, we have a square. So we can either go through the same route of finding that height or that apothem using this analysis, or we could just consider that this is a square. So an area of a square is side times side, so side square. And we can just look at the side as 15, so it's just 15 times 15, 15 squared. So the area for this would be, let me see, 15 times 15, 225. And that's it. That's the answer for that. Earlier in a class, I did it the other way where I had to find the apothem with special right triangles or SOHCAHTOA. So here's the work for that in case you want to see it. We divided the triangle that's created right there, which creates a 90-degree right there. And then we only want half of it, so it creates 45 angle right there. So we have a 45, 45, 90, which creates the relationship of these two sides being equal. Based on this, 15, the whole thing, half of it will be 7.5. So 7.5 right there and 7.5 right there. So the apothem is 7.5. With that, we apply the perimeter, which is 15, 15, 15 all the way. So that's 60. And then we typed it in and it came out to 25. So we got the same answer. You just got to pick which route you want to do. All right, so all this crazy math is usually used in hexagons, octagons, pentagons, all of those shapes that we are not too familiar with. So here's an example of another one. This is a hexagon. They are pointing to giving you the apothem, but they're not giving you the side. So you still have to do some math here to calculate what is the side. So you can do the formula of 1/2 times apothem times perimeter. So to find this side, we need to analyze, again, visualize the triangle. There's a hexagon, so we're going to do 360 divided by 6, so we can find out what one of these angles is. And that gives you 60. So you have a triangle that is 60 degrees right there. And to find these angles, well, we do once again 180 minus 60, so that's 120. So these two angles together give you 120, and they're equal. So 120 divided by 2, that's 60. So these are also 60. It's an equilateral triangle. But we're trying to find the apothem. So let's now look at it as half of it. So we're going to have a 30-degree angle right there, a 90-degree angle right here, and a 60-degree angle right there. So that creates the relationship of a 30, 60, 90. The side that has a 90-degree and a 60-degree, that's labeled x. And then the longer side that's with the 30 and 90 is x squared of 3. So I'm going to label this as x, and this is as x squared of 3. And according to this, the 5 squared of 3 is the apothem. So we can visualize this as 5 squared of 3. And now when you stare at this and you make a connection. So if this is true, then that means x is 5. So if this bottom part is x, then that means this bottom part is 5. And that's what we were looking for. We were looking for the side, the bottom part. So if this is 5 and this is 5, together the whole thing will be 10. So in other words, we're looking at a hexagon that has 10, 10, 10, 10 all around. So the perimeter for that will be 60. And then the apothem is what they gave us right here. So 5 squared of 3. And then 1/2. So you type that in the calculator and you got your answer. So 1/2 times 5 squared of 3. And then times 60. So 259.8. 259.8. Okay, let's do one more. We have number 5. This is an octagon. So we're going to do 360 divided by 8. 360 divided by 8 gives you 45. So 45 is the angle that we have created right here. So if we have a triangle that's 45 together, we only need half of it. So that means we're going to do 45 divided by 2. And that's not 11.25. It's 22.5. So 22.5 is the angle up there. We know this is 90 degrees, and we just need to find what this angle here is. So going back to this, if this is 45, we got to do 180 minus 45. And that will give you 135. Then we got to divide 135 by 2 because these two are equal. Divided by 2. 67.5. So 67.5 right here, 67.5 right there. So this angle right here is 67.5. All right, so if we're looking for the apothem right here, we don't have that. We do have that this whole thing is 10. So if this whole thing is 10, half of it, if we split this in half of it is 5. So this is 5. All right, and then again, this is not a 30, 60, 90, so we do resource back to SOHCAHTOA. And just pick an angle to start with. So let's say we do 67.5 now. So 67.5 related to x is opposite. 67.5 related to 5 is adjacent. So we are still going to use TOA. So we're going to write tangent of 67.5 equals opposite, which is x, over adjacent, which is 5. And then you're going to multiply both sides times 5. Cancels that. And that leaves you with x. So type that in the calculator together. And that should give you the x value. So we're going to type 5 tangent 67.5. And it's 12.1 if we round it. And that again is the apothem. So we're going to use that in our formula of 1/2 AP. So 1/2 times 12.1. Perimeter of this, we have 10, 10, 10, 10, 10, 8 times, so that's 80. And then we do 1/2 times 12.1 times 80. And it's 484. So the area is 484 inches squared. All right. One more question. And again, this one is just an easy one because they're giving you the apothem and they're giving you the side. So you're basically just filling in the formula. So whenever you're given the apothem, just be thankful, smile. You don't have to do any work. You just gotta substitute the values in the formula. 10.9 is the side. This is a pentagon. So you do want to multiply 10.9 times 5. And that will be your perimeter. So then we're going to type 1/2 times 7.5 times 10.9 times 5. Oh, I forgot the decimal. Okay, that should do it. So 204.4 meters squared. All right, so these 6 problems should be enough to help you practice the 4 problems in the back. If not, just come to tutoring. I'll help you. All right, hope it helps you.